Hey guys, welcome to part 2 of my video on indices. Today we're going to run you through all the common styles of exam question that can come up involving indices. This includes basic rules for combining indices, algebraic expressions, changing the base for indices, and then last we're going to finish up with algebraic expressions with multiple variables. We're going to be using all the stuff that I mentioned in part 1 of this video, so if you need to brush up on any of the theory, you can find that video here or in the link in the description. Hope you find this helpful. Let's jump straight in. So the first question we have here, we're just combining some indices using multiplication and division, it looks like. So part 1 is multiplication, so that's just adding the indices, or adding the powers, sorry. So for part part 1 is going to be 3 over 2 plus a half. So that'll be x to the 3 over 2 plus a half, which would just be x squared. For part 2, now we're doing division. It's x to the 3 over 2 divided by x. X written like that just means x to the 1. So it would be x to the 3 over 2 minus 1, which would just leave us with x to the half. Then the last example we've got here, we've got x to the 3 over 2 all squared. So that's the nested powers rule. So we just multiply the two different powers. So for part 3, we have x to the 3 over 2 times 2. So those 2's will cancel out effectively, leaving just with x cubed. So next up, we need to identify the expression below that is equivalent to e to the minus 2 over 5. Well, the minus immediately means it's going to be a reciprocal, so we could easily eliminate these two things here. And then the fraction of a fifth means it would be a fifth root of something. So we definitely can write e to the minus 2 over 5 as 1 over the fifth root of e squared. And that 2 also makes sense if we think about the nested powers rule. So that would be this answer then. Next question, it says, can we simplify a to the 2/3 times a to the 2/5 all wrapped up in a square root? So let's start by just simplifying the inside of the square root, and we'll deal with the square root afterwards. So that would just be the square root, and then to simplify inside, we just add the powers. So 2/3 plus 2/5. And then we could write both of those over a denominator of 15, both those powers. So 2/3, that would be 10 over 15, and 2/5, that would be 6 over 15. So that would be the square root of a to the 16 over 15 if we add those powers together. And then we remember that a square root is simply just a power of a half. So we really have a to the 16 over 15 all to the power of a half, which is just a to the 8 over 15, because you just need to multiply those two powers together. So that leaves us with the answer that's this third option here. So next question, it says, show that 4 plus 3 root x all squared in a bracket can be written as 16 plus k root x plus 9x, where k is a constant to be found. So we just need to expand this bracket. Let's start by just writing out both brackets. So that would be 4 plus 3 root x times 4 plus 3 root x. We've got to make sure we carry out every multiplication here. So the first one I'll do is 4 times 4. So that would be 16. Then we'd have 4 times 3 root 6, which would be 12 lots of root 6. Now if you move over to the second term in our first bracket, we'd have 3 root x times 4, which would be another lot of 12 lots of root x. And then 3 root x times 3 root x, well, 3 times 3 would be the 9, and then root x times root x, if you remember, that would just be x. So we'd get 9x. And if we bring this all together, we'd have 16 plus 24 lots of root x plus 9x. So k then would equal 24. So the next question for part A, it says write root x in the form of x to the k, where k is a fraction. So that's just a recall thing, basically, like a square root is simply a power of a half. So for part A, that would mean k is just equal to a half. And it says hence express the square root of x times x minus 1 into the in the form x to the p minus x to the q. So we need to multiply that bracket. Let's first write it down in this power form that we've just deduced. So it'd be x to the half times x minus 1. And then x to the half times x, or x to the 1, we just add the powers. So that would be x to the 3 over 2. And then we'd have x to the half times minus 1, which would be minus 1 lot of x to the half. So we'd have p then is 3 over 2, and q is a half. Next it says, given that 6x plus 3x to the 5 over 2 all over root x can be written in the form 6x to the p plus 3x to the q, can we write down the value of p and q? So we need to simplify this expression, basically. So the first thing I'm going to do is write everything in powers of x. So we just need to change the denominator, actually. And we can split this up into two separate fractions, because there's two terms in the numerator. So I could write this as, for part A here, I could write this as 6x over x to the half plus 3x to the 5 over 2 over x to the half. And now we've just got division going on. So we can use the division rule for indices, which is just to subtract the powers. So we've got the first case, x to the 1 over x to the half. So 1 minus a half is a half. So we'd be left with 6x to the half. And then the second case, 5 over 2 minus a half would just be 4 over 2, or 2. So we'd have plus 3 lots of x squared. Next question, it says, can we express 3 to the 7 over 2 in the form of a root b, where a is an integer and b is a prime number? So actually, 3 already is a prime number. So if we can work the square root of 3 into this, that would be a good plan. That's going to work out, actually, because if we have 3 to the 7 over 2, 3 to the half is the square root of 3. So we could split up that 7 over 2. We could think of it as 6 over 2 plus a half. And now if we recall what addition of powers is, it's really multiplication of indices. We can think, okay, well, that's 3 to the 6 over 2, which is really 3, times 3 to the half. 3 cubed is simply 27. And then 3 to the half is just the square root of 3. So we have our a and b, where a is 27 and b is 3. Okay, so now for question 3, it's saying, can we express all of these numbers with a base of 5? And so the part 1's quite nice, because 25 is a power of 5. So if we just start by writing 25 as 5 squared, so that would mean we'd have 5 squared all to the 4. And now we can simplify this down using the nested powers rule. We just multiply out the two different powers. So 2 times 4 is 8, so that's just 5 to the 8. So k is 8 in the first case. Then part 2, we've got 1 over the 4th root of 5. So first off, we can deal with the 1 over by thinking that this is a negative. Actually, let's deal with the denominator first. So let's think of the 4th root of 5. That would just be 5 to the quarter. So we'd have 1 over 5 to the quarter. And then to deal with the 1 over now, we can just think of that as a negative power. So that's equal to 5 to the minus quarter. So k in this case would be minus a quarter. Okay, so now for part 3, we've got 5 root 5 all to the power of 3. Let's start by just simplifying inside the brackets, because we can think of that as 5 times 5 to the half all to the power of 3. So 5 times 5 to the half is just 5 to the 3 over 2. So we'd have 5 to the 3 over 2 all to the power of 3. Then we use the nested powers rule, just multiply out those two powers. So 3 over 2 times 3 is just 9 over 2. So we'd have 5 to the 9 over 2. So k in this case is just 9 over 2. Next up, we've got some equations to solve. So the first one, that's quite straightforward. 8 is just a power of 2, like 8 is 2 cubed. So we can just state that y would be 3. And then the next one, that looks a bit more interesting. The thing to spot is everything has a different base. We've got a base of 2, a base of 4, and a base of 8 going on. So we could simplify everything quite considerably if we wrote it all on the same base. So nicely enough, 4 and 8 are both powers of 2. So let's write them in base 2. So we'd have, we'll leave 2 to the x, that's already in base 2. Then we're multiplying by 2 squared to the power of x plus 1. And that's all equal to 2 cubed. And now if we start simplifying the left-hand side, 2 squared all to the x plus 1, well, we can just multiply out those two powers. So that's going to leave us with 2 to the x times 2 to the 2x plus 2 equals 2 cubed. Now we can combine these two indices here with the multiplication rule. So you just need to add x to 2x plus 2. So that's just 2 to the 3x plus 2 is equal to 2 cubed. And now if we just compare both sides of this equation, they're both in base 2. So if these guys are equal, the powers need to be equal also. So we can just skip straight ahead now to 3x plus 2 must equal 3. And then from there we can solve quite easily, like we'd have 3x is just equal to 1, and then x must be equal to a third. So next up it says, given that 9 to the power of x minus 1, all divided by 3 to the power of y plus 2 equals 81, can we express y in terms of x, writing your answer in its simplest form? So the first thing I spot here again actually is that everything can be written in a common base of 3, because 3 squared is 9, and then 3 to the power of 4 is 81. So let's start by doing that. So we can write 3 squared all to the power of x minus 1 divided by 3 to the y plus 2. That's all equal to 3 to the 4. Now let's move this up here just by multiplying. So we'd have 3 squared to the x minus 1 is equal to 3 to the 4 times 3 to the y plus 2. Now we can start simplifying on both sides. On the left-hand side, we can use the nested powers rule. So we've got 2 times x minus 1. That would be 3 to the 2x minus 2. On the right-hand side, we're just multiplying, so we're just adding the powers. That would be 3 to the y plus 6. And now we're in the similar situation again, where we've got the same base, and if these two things are equal, the powers are going to have to be equal. So we'd have 2x minus 2 must equal y plus 6. And then just to express y in terms of x, all I've got to do is take that 6 over the other side. So y then would just be equal to 2x minus 8. So now we've got an expression involving multiple variables. So it says, can we simplify 3xy to the 4 all cubed, all divided by 6x to the 5 y squared? So let's start by handling the multiple powers in the top. So we can just apply that power of 3 to everything in the bracket. So we'd have 3 cubed, that's 27. And then x to the 1, all to the power of 3, multiplying those powers, that would just be x cubed. And then y to the 4 all to the 3, 4 times 3 is 12, so that'd be y to the 12. And then we just have what we had before on the bottom, so that's 6x to the 5 y squared. And there's no common factors between 27 and 6, so there's nothing to cancel there. But we can cancel out some x's, so we can actually cancel out all of these with the bottom, leaving just a power 2 on the bottom. And we can cancel out all the y's on the bottom, leaving just a power of 10 on the top. So that would leave us with 27 y to the 10 all over 6x squared. And if we want to write this, well, at least write the variables not as a fraction, we could write this all as 27 over 6 times x to the minus 2 y to the 10. Okay, and now for the last question, we got something similar, just a bit more work to do. Let's start again by just simplifying that top bit. So applying that power of 3 to everything in the bracket, we'd have 4 cubed, which is 4, 16, 48. And then x to the 5 cubed, that's x to the 15. Then we'd have y cubed. And on the bottom, we've got 2xy squared times 8x to the 10 y to the 4th. So we can start pairing up the numbers and the x's and the y. So 2 times 8 is just 16. X to the 1 times x to the 10, that would give us x to the 11. And y squared times y to the 4, that would leave us with y to the 6. And now we can start simplifying. 48 is actually a multiple of 16. It's 3 times 16, so we can completely cancel out that 48 and just leave us with a 3. X to the 15 divided by x to 11, all the powers of x on the bottom will cancel, leaving us with 4 powers on the top. 15 minus 11 is 4. And then all these y's on the top will disappear, and 6 minus 3 is just 3. So we'd have, in the end, we'd have 3 x to the 4 over y cubed. And again, if we want to just write this all as not as a fraction, we can just use a negative power on that y, and we could say that's 3x to the 4 y to the minus 3. So that's everything for this video, guys. I hope you found it helpful. If you did find it helpful, please drop the video a like. That really helps me out. Also, consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.